Welcome to another episode of Modern Infrastructure as Code. I'm your host, Lee Zen, and today I'm joined with Cameron Stokes. Hey, Cameron, how's it going?
Hey Lee, doing well. How about yourself?
Great, thanks. I'm really excited to have you join me today. I think we're going to be talking through a lot of fun stuff related to policy as code. And we're just going to start by looking at a project right here. And in this project, we're going to be talking about some very basic configurations. We're going to start with using some AWS. We're using TypeScript today with Pulumi. And we're going to create a very simple stack. We're going to first create a VPC with just one availability zone and a public subnet, and then we'll create a security group for that VPC with ingress for port 80, and then we'll create some web servers to be able to talk on those ports, and pretty simple configuration here. We'll have a certain number of instances based on some config we import from a different file. But let's just see how this runs. And while this is running, so right now we're previewing an update as if we were to deploy this. So while this is happening, Cameron, I guess the question I have is, how do we make sure that what we're going to deploy is actually going to do the right thing in terms of not violating any policies we might have as an organization?
Yeah, so we can do some pretty basic things like we've already done in this code, which is like setting a common set of tags as in base tags on line 10 there that we then reuse across our VPC and security group and instance. That's one way to kind of get consistency across resources, but it's really easy to just omit that or to omit the stack tag as a part of that and violate those policies that you talked about. So really what we want to do is use Pulumi's policy as code feature to enforce that certain properties of our resources are there and they're set to certain values, and basically just kind of put some compliance and governance in place using policies code.
Awesome. So if we look at this preview, it looks like it would have created these three instances along with the security group and the VPC, along with all the related routing that we talked about earlier. So why don't we try to get some policies in place? It looks like we have a handy file open here already, Cameron. And do you want to walk us through this?
Yeah, so this is one of our policy packs that is actually configurable. So within this, we're going to check for a few, or rather two different kind of checks or policies within the stack. And they're configurable, meaning that we can have different config values set for different stacks. So in this case, we're going to check for the particular instance type or the class of instance types that are used for our EC2 instances. And we're making the allowed instance classes value configurable. So down on line 20, you'll see where our policy check or our function actually begins to do that check. So on line 21, it's going to pull in that allowed instance classes config value. The value of this is going to be like T3 or T2 or C5 and so on. It's going to be an array of those. And then on line 22 and the next few after that, it's basically going to check that our instance type is of one of those instance classes. So if our instance type is set to T2 medium, check that it's of instance class T2 based on the config value. And if it is not, report a violation and say that our instance type is not of allowed instance classes. The next policy down is going to check for the maximum number of instances in this stack. So again, we have a configurable value that actually has a default, in this case, of 5. And then on line 40 is where we're actually going to do our policy validation or our policy check. In this case, it's actually acting on the entire stack, so not just a single instance or single resource type as in the previous one. So it's basically going to do a count or do a filter for type of AWS EC2 instance, define the total number of instances, and then just compare that to that maximum instance count.
Got it. And so, in one case, I'm validating stack. In the other case, I'm validating resource, as we saw earlier for the EC2 instance types.
Yep.
What are some scenarios where I would want to validate the stack versus just validate the resource?
Yeah, the main difference is, so on line 20, where you're validating an individual resource, or you're specifying the resource type that you want to check, so that validate resource of type AWS EC2 instance. And then when Pulumi's policy as code implementation runs, it'll basically iterate over every resource in your stack, and if it is of type AWS EC2 instance, pass it into this function to do that check. Validate stack, on the other hand, gives you the entire list of resources in your stack so that you can do like aggregate checks. So in this case, we're counting the number of instances to be able to compare to our maximum instance count config value. Another use case for validate stack is doing cost estimation. So in a similar manner, we could basically filter out all the AWS EC2 instances and then do a cost estimate based on running them for an entire month, and then add that up over the course of a month effectively, and get that estimate, and then compare that to a budget. Is another use case for doing a validate stack call.
Got it. Makes sense. And what if, in both these cases, we actually have some configuration values either defaulted in or, we're passing them in to the policy? What if I don't need, any kind of configuration whatsoever?
Yeah, so there's a call it a regular policy that you can write that actually doesn't have any configured values, and that can just kind of do more static or hard-coded checks. So in the file that you're about to open, we do that across a number of different policies to check for certain properties on the resources themselves. So like in this first one, where it's, the name of this policy is discouraged EC2 public IP address. Again, we're doing a validate resource check, so just acting on a single resource type, in this case of AWS EC2 instance. And then we're checking that the associate public IP address property that has been set in our code, in our actual Plumbee project, is not set to false, or rather is set to false. And based on that, we're going to report a violation that associate public IP address should be false. And in this particular policy, this one is set to advisory, whereas in other policies down below, you can see that this enforcement level is set to mandatory. The distinction there is that if a violation is reported on an advisory policy, it'll print a warning, but it'll actually let you proceed with that deployment and proceed with that up. Mm-hmm. For a mandatory violation that is found, it will actually halt and print you that warning, but then not let you actually proceed with continuing with that deployment.
Got it. Cool. Looks like there's a couple other policies here. Let's try running this with the policy pack so we can, oops, I can't type. Yeah,
so what you're doing now is just running that preview with the kind of more like static policies as we described, so the ones that are currently on your screen. They're also going to check for like ingress rules on security groups. So in our case, a security group is set to allow ingress from a private network space. So we actually won't see a violation for this one because it's checking for public internet access. But you can see for the violations that were printed here, we do have associate public IP address set to false, and it's reporting a violation for each instance that was found to have violated that in our stack.
Cool. So let's try, I guess, turning that off, and we can see what happens.
Yes, is that the false, and we should see that that violation go away.
And so while this is running, you talked about advisory versus mandatory. What are some use cases where you'd want to have the mandatory check? I really get. It's like, hey, let's just not do this. Where does the advisory check come into play in your mind?
Yeah, so kind of along the lines of like the instance class policy that we talked about before. So let's say you might want to allow larger instance classes for specific projects, but you still want to warn against them, right? Some of the instance classes or instance types at Amazon and Google and Azure and so on can be quite expensive, quite costly.
Yes.
But again, there might be a use case for them, so you could check for that. Another kind of use case for advisory is if you're actually rolling out new policies to your team. You want to give your team time to adapt and kind of incorporate those new policies into their code. So let's say you want to put in a new policy for 3 months from now. You can set that policy to advisory. In the message on the policy itself, you can say this will be set to mandatory as of July 1st, and now you're giving the feedback to your team every time they do a deployment that they need to go ahead and incorporate that into their project, and then come July 1st, switch that over to mandatory, and now it's required and it is enforced across all of your stacks.
Right, that makes sense. Yeah, that makes sense. I mean, you want to give people time to respond, right? You can't be so heavy-handed. Cool. Should we try removing some of these base tags, like, to see what happens then? So we talked about how those tags are required. So I should mention, so the earlier run we can see was clean, because we actually turned that flag from true to false. Oops. Oh, I think, is it because
So the policy is actually only checking for tags on
odd
instances in this
instances?
case.
Yeah.
Yeah. So if you, yep, go down there and move. So this one's a bit more complex because, if I remember right, it's checking for a name tag, a project tag, and a stack tag. And so we should see 3 violations for each instance. And in this case, we're provisioning 3 instances. So we'll see several violations reported here.
Right. Right. So
and we're not just checking that they exist. In this case, we're checking the value as well. So we want our project tag to be set to our project name, and we want our stack tag to be set to our stack name, in this case, dev.
Right. So we can actually have some pretty complex rules in here, as we saw earlier, where it's, you're actually doing, using real code to check these kind of conditions.
Yeah,
Cool.
exactly right. And based on the stack name, the check is different, right? It's checking for stack is set to dev, or if you're on your prod stack, it would check that stack was set to prod.
Okay, so I put these tags back in, so we won't get that policy violation anymore. Should we talk about a little bit about how to run the configuration based policy packs?
Yep.
So earlier I was doing this, but now we want to run the config based one. How do I if I recall correctly, it's like this, right? And
yep. And now you're going to pass a JSON, a path to a JSON file that has the configured values in this case. Yeah.
Let me see what stack I was on. I'm on dev. So do this. And let's take a quick look at this while that runs. So yeah, I think earlier we defined these, right?
Yeah, so this is based on the policy name. So like allowed dash instance classes is the policy name, and then allowed instance classes in camel case is the actual config variable name essentially that we want to set. And in this case, it's an array, whereas maximum instance count is just an integer.
Right. So if we go back to this code, here we had this integer, like you just talked about, and this is that name, or sorry, this is that name. And then up here we had the allowed instance classes where it was an array. Okay, that's pretty self-explanatory, I guess. And it looks like we violated that. So if I look at my config here, I guess I have 3 instances configured, and I guess that's not allowed. Cool. So we can actually just switch stacks, I guess. And so I can do the same thing and just really just change the configuration I'm running against. Is that kind of how you would imagine this working in practice?
Yeah, that's exactly right. Is you can, based on the stack that you're working with, in this case prod, use a prod, a set of configured values for the policies in this case.
Cool. And so in this case, if I look at my config, I have still 3, but now I have a different instance type. And in the prod case, these are allowed, and I'm well within the maximum instance count.
Yeah. So just to kind of see the full picture, if you were to change your instance type from C5 large to T2 medium, which is what our dev value was, and rerun it, you'll see a violation of that particular policy.
Oops. Instance type.
Yep. So in this case, the kind of real world usage of this would be to enforce that you're using kind of less expensive instance classes in your dev environment or in your non-production environment. But for your production environment, where you likely have higher usage, you have more users, you have higher load, you need to use kind of more optimized instance types. you can set a policy that allows those higher classes or higher instance types in production, as an example.
Awesome. And so, we ran this set of configuration based policies. We also had the non-configuration based policies earlier. Can I mix and match those two kinds of policies together?
Yeah, you absolutely can. So when you're specifying the policy pack flag as well as the policy pack config flag, they just take essentially an array or a list of packs and then of configs. So yeah, just do comma policy pack or policy as code rather. And since that one doesn't have a config value or config path, yeah, you can just do a comma there. Yep.
And so I think, if I recall correctly, we had all passing on the second set of the second pack, and we should fail the first pack. And then if we fix our configuration, oops, oops, I don't know why I typed AWS. Do Pulumi there. So I should have the correct configuration now for going into production.
Yeah, exactly right. And in this case, you're in Pulumi preview, so it just ends and exits and shows that you have a clean preview. If you run a Pulumi up or Pulumi update, it would actually allow you to then proceed with that deployment. Whereas if you still had violations that were set to mandatory, it would exit until you had to fix those before you could continue.
Awesome. And one thing we haven't talked about is, how do I share? I have this policy on my developer box. How do I share this policy with the rest of my team?
Yeah, so like you said, what you've seen so far is running it from your local machine and referencing that local policy pack through the Pulumi console. So through our SaaS platform, effectively, you're able to publish these policy packs and also set the config values into the Pulumi console. And from there, you can actually set organization-wide policy and pick and choose this policy pack to apply to dev with this particular config set in it as well, as we showed here. But then also have the same policy pack, but with the production or the prod config sets to apply to your prod stack. So through the console is where you're able to get that organization-wide application and enforcement of policy.
Awesome. And then when I run it next time on my desktop, I'll get those configurations.
Yeah, that's exactly right. So if you publish those to the console, set the config value, and then enable it for your specific stacks, the next time you're in a Pulumi preview without all those policy pack flags and arguments, it'll basically handshake with the console effectively, and then download that policy pack and run it in the same ways we saw before, but now without you having to remember to pass those flags and get
Awesome.
Strong enforcement of that.
Awesome. Well, I feel a lot more safe knowing that we're doing the right thing here and that we have our stack configured correctly. So thanks for walking me through this, Cameron. This was super helpful.
Yeah, you're welcome. I enjoyed it.
Awesome. Well, hopefully we'll see you guys next time on Modern Infrastructure as Code. We hope you enjoyed this episode about policy as code. And yeah, we'll see you next week.